Hi guys, welcome to episode 6 of our ReliaCast series. Each episode we cover a reliability engineering topic. If you haven't seen any of the other videos yet, please check them out. The previous episode are on LinkedIn and YouTube. I'm your host today, Chris Wynn-Jones, and joining me I have my colleagues Bartek and Mariusz. So guys, would you like to introduce yourselves?
Okay, so my name is Bartlomiej. I am senior application engineer, HBK, 6 years already with the HBK, but over more than 10 years in availability engineering world. And as a senior application engineer, I am daily supporting users of our ReliaSoft application. I'm supporting developing reliability analysis and reliability management programs.
Thank you, Bartek.
I'm Mariusz Dąbrowski. Not the first time in this video series, so you should have already known me. I'm an application engineer at HBK, 2.5 years, and in total 15 plus years experience in reliability engineering, and I'm based in Warsaw, Poland.
Thank you guys, thanks for the introduction. So yeah, the three of us, we all work under the HBK, all application engineers, and all have an invested interest in reliability engineering of various different angles. Up to this point we've been discussing failure management effects analysis, live data analysis, using the Weibull tool to generate those Weibull analysis, and the use of that Weibull analysis to support failure management effects analysis and understanding the failure modes, failure mechanisms, and the frequency of failure. So the likelihood of something failing, things like that. We covered those topics, and we branched out a little bit, touching on RCM, touching on optimum replacement, and also task management was something that somebody asked about at one of my face-to-face seminar that I went to. Got approached and asked about that. So today's video, introducing the topic, we're going to be covering these topics that have been hanging over from previous videos and bring them all into one. So today's title: Reliability Centered Maintenance, RCM, availability with optimum replacement, and the impacts of that, and branching into the generation and management of tasks in our application tools. So from the top, for me, everything starts with the failure management effects analysis. We go into RCM with an idea of what failure management effects analysis is. The design and process for me is that we produce failure management effects analysis for those topics. The actions and controls that are raised in those look backwards to improving the design or improving the process. In RCM, correct me if I'm wrong, we're looking the other way. So we're using the failure management effects analysis to help us to identify maintenance tasks. So instead of controls and actions, we're looking at reliability policy, which comes from the Weibull analysis that we were talking about in previous videos, and added to that the tasks. So reliability policy and task. So we're looking into the future with the failure management effects analysis sat there in place. So on the first part, the RCM discussion, I mean, it's far away, guys. You agree with me? Is this the right mindset with where we are in these tools?
Yeah, that's correct, Chris. Yeah, like usually for the RCM and this part of the FMEA that we are doing for the RCM, usually the last thing that we can do is design change. Yeah, so we are trying to do as much possible with the maintenance optimization and doing this in the right way to preserve our assets. Yeah, design depends on an approach. It's allowed, as I said, yeah, usually as a last option. Yeah, because of course if you have some quality issue, we will not do this with the more maintenance. Yeah, we need to also make some actions, yeah. And sometimes the actions would be that, okay, let's redesign, so make a additional redundancy. Let's change supplier, yeah. So also this could be considered, but as I said, usually as a last action. And the key difference is also about the causes level of the casuation for both like the design FMEA, process FMEA, and FMEA for the RCM, yeah, because for the RCM we need to end up on an actionable level. For that we can perform maintenance activities. So this is the one of the key differences.
To optimum replacement, what is optimum replacement, and what's its benefits and uses within maintenance analysis?
Of course, yeah. So one, of course, also for RCM is to find the maintenance task that is feasible and worth doing, but on a RCM methodology, we need to make this in a cost-effective way. Yeah, so to make this in the best possible way. This is also regarding the rigorous approach, finding the maintenance task, because we can compare different maintenance tasks. If they are both or three of them even more worth doing and feasible, then we can go on to another step of the optimization of the maintenance task, finding the optimum replacement time. Yeah, but of course then we need to find what is the cost of the preventive action if we are optimizing the scheduled replacement, what is the cost of the run to failure strategy, so unscheduled event, and we need to have a reliability model. Yeah, and only based on the key principles of the reliability, only the models with showing the wear out can justify scheduled replacement. And the one,
yes, this was actually what we already discussed during last episode about this, that we cannot use it when there is constant failure rate, when there is decreasing failure rate, so that's infant mortality. We cannot really use it. So yeah, it's worth to remind it to everybody, definitely.
Yeah.
I'm thinking also, so we were talking about the replacement, but actually in RCM, maybe I'm going too far at the beginning, but the RCM has a lot of options for task selection. Yes, so you can select really a lot of different tasks. It doesn't have to be part replacement, and that is also what is very different from the other tools that also offer optimum replacement functionality, because this functionality is also present in Weibull, in BlockSim. So I don't know, Bartek, if you could say more about those different types of tasks that we can select in this RCM process.
Yeah, of course, yeah, the task and the maintenance strategies, yeah, because this is what I said, run to failure, yeah. So run to failure, we are doing no any scheduled maintenance. So yeah, we are allowing to our assets to go to the fail. Yeah, of course, based on the RCM, we know what are the consequences. Yeah, so if this is just economic consequences, we can run. Yeah, we can run and we can wait for such a failure. And if from the cost perspective analysis, this is more efficient, we are doing this run to failure. Yeah, of course, the other is condition-based maintenance. When we are checking the current status of the system, if it is about to the failure, it can be physical condition-based maintenance. It can be online condition-based maintenance. Of course, this is in our tools as on condition task. We can do number of the services, inspections, like the lubrication that can restore our age of our system in a smaller degree, like the scheduled replacement. Yeah, scheduled replacement. Yeah, the next strategy on a scheduled basis, based on the age, or based on the calendar time, or based on the some events for the item and system, we can schedule some activities. Yeah, this is the the examples of the maintenance tasks that we can consider. And of course, doing this analysis of the looking for the optimum replacement type, we need to be also aware that usually for the cost of the unscheduled events, we are underestimating this. We are usually not covering all of the costs that are coming to the organization. In example, cost of the reputation, cost of the additional activities that people are doing around such an unscheduled thing. Because it's usually changing the schedule of the day for many of the people. We are sometimes experience this, that we have a scheduled meeting with reliability engineers and we need to reschedule this because by something unexpected happened for the value asset, and this is usually not taken into account when we are estimating unscheduled events cost. So what I am trying to say, we need to be unscheduled. If we have a comparable cost of the run to failure and scheduled replacement activities, if they are comparable or even a bit better run to failure, I would say in the reality it will be that the scheduled still will be better, because this is usually where what is underestimated. Underestimated is unscheduled events costs.
Yeah, that makes a lot of sense.
Yeah.
Thank you. You have a nice experience with RCM.
Yeah.
But we kind of, or I, asking this question, I kind of started from the end because actually, the selecting of the task, the maintenance strategy, as you said, is probably one of the last steps in the process. That's also the most important things to do in RCM.
This preparation is always important. To understand your asset. The asset that you are trying to analyze. Usually, this is like the thousands of the items. So doing these activities of the risk, how we are calling this in our tools is risk discovery. But by different industries, it can be made any significant items, critical items. So we are trying to make some prioritization on what items we need to first do our analysis. To get the most benefits. Not starting, from the alphabet or from the list by the numbers. But trying to make some ranking of them, and one of the method is just this question, yes and no, if we have some safety issue, if we have economic issue, operational issue for the items, the other can be more like risk matrix, so trying to evaluate what is the ranking for the safety, how many people can be injured, environmental issue, economic issue, so more sophisticated methods. We can take also output from the ERP systems and get the information, how many events we have, or from the fracas systems, for what items we have the most failures, what are the most cost of our maintenance activities, and then based on that make this prioritization. So this is one of the activities that we should do, and also we need to learn what is our asset. If we are from the company. Within the company, it's easier. We can do this with the cross-functional team. If we are external consultant, we need to have a close cooperation with the people that knows the asset. And one of the very undervalued step of the RCM analysis, or understanding operating context of our asset. Because it depends, on what conditions, on what environment is the asset it's working. So this is one of the trap of the streamlined RCM and doing the copy paste, without taking into account what is the operating context, if we have any redundancy, standby configuration, what is the liquid that we are trying to transfer, even if we are using the same asset, So operating context, this should be the pre-work before starting to identify our functions.
Thank you, Bartek. So just briefly over the process. So we go through that analysis, and we're looking at the tasks. We're looking at the optimum replacement where possible of an existing analysis. We could modify that replacement time, so we could have replace every 3 months, and the optimum replacement might calculate to replace every month because of the way that the reliability policy works and what it presents. However, that could be optimistic or pessimistic, whichever way around you want to look at it, depending on which side of the coin you're on. But for it to fit, it might not be realistic, because mathematically it says what it says, but practically 3 months is a practical date. So is it possible to actually change that sooner or not? And like you say, depending on availability of other aspects, depends on whether the availability of this particular item is correctly calculated. So we do need to be careful of that. Okay, so moving on really to the next part. So we've done the RCM++ tool, as I was saying before. And with the RCM++ tool, we get to a certain point, and very similar to the FMEA tool, in that we produce a series analysis, and RCM++ is the same. And there are a lot more we can do with it if we then link that over to the BlockSim tool. So within the BlockSim tool, we can look even deeper into maintenance schedule with simulation. So with the simulation, we can see a lot more detail and a lot more predictive capability, I think is the best way to describe it. So I mean, either you two guys or both of you fire away with what we get into the BlockSim tool. We have a reliability block diagram from our RCM++ analysis. So what do we do with it from there?
Yeah, so this comes back to the topic of the last session, the episode about the FMRA, because this FMRA can be both done in our XFMEA and RCM++ tools. But yes, you're absolutely right that there's this limitation that the configuration of the system has to be serious. So if you want to do a simulation, we can do it, but only for the serious configuration in those tools. If we want something more, then we have to switch to our BlockSim tool, where we can perform analysis of reliability, analytical methods, and also use simulations to calculate the availability, maintainability, put these additional metrics into play. And not only that, also some more cost analysis and so on. So these all tools are kind of working together, and it strongly depends on what are your needs, what are the customer needs. To this will determine the selection of the program that needs to be implemented in an organization. I don't know, Bartek, if you've got anything to add. Well, actually, comparing to XFMEA and RCM++, it's not only the configuration that we can benefit from in BlockSim. Yes, it's because we can have this parallel configuration. We can have K out of N parallel configuration, some more complex configurations with load sharing, standby, mirrors, maintenance groups. So there's a lot more that can be done. But again, that depends on the needs. Bartek, if you would add also something.
Yeah, of course.
BlockSim.
As you said, in the BlockSim we can add much more additional example redundancies, additional strategies, how the assets will be operating, so it gives you more flexibility in a block sim. It also is on RBD, so RBD block diagram, so more visual, easier to follow, to present our systems,
Or fault tree if needed.
if fault tree, so both are integrated, also we can have with the tools, RCM++ and BlockSim, ReliaSoft tools, they could be integrated, and it could be integrated in two ways, that one is like the just taking output from the RCM++ based on the RCM or FMEA analysis and build automatically your models, your RBD or fault tree. Another way is that you can use FMRA and have it still integrated. So any changes is done for the RCM, FMEA. You can see this automatically in a block sim, and on the reverse, one more comment apart from I agree with you, Mariusz, everything. One additional thing is the capabilities regarding the reporting in a block sim. That you can see this much from the many different perspectives. You can get these tables, with the very detailed results regarding the key KPIs of the system, availability, mean time to between failures, mean time to maintenance, and much more, on a system, subsystem, components level, so we can go deeper with the understanding what are the bottlenecks of our systems, also with the visual aspect, so taking a look on plots where you can see this all of the key numbers plus customized dashboards, so much more reporting capabilities. And also very important in a RCM++, we have a cost availability comparison regarding the maintenance strategy comparison. In the block sim, we can see also number of the events, and that is very important for the safety consequences, where we can exactly see for the years of the operation for how big risk we can allow, so what is our risk, and if this risk is tolerable for us or not tolerable, and then we can perform maintenance in the other way, so we can touch the number of the events.
BlockSim is a huge tool, very, very helpful, and we are only touching on the surface of it right now. There's so much more functionality, like event analysis, for example, and more. I think this could actually be a topic of a whole episode.
A series of episodes.
Or series.
Yes. a series of episodes, absolutely. Going down that route. But so this series so far, we've been looking at RAM analysis, reliability, availability, maintainability, and touching on a mix in each of the over the whole thing as a mix of these three topics. But that's RAM analysis. I mean, there is design for reliability, and we've got design for maintenance, and we've got other things as well, like in the BlockSim tool with throughput analysis. There's throughput tools and all sorts of things in there as well. So there is a lot of things that we could be discussing. As I mentioned many times before in the previous videos, as the audience who are listening, please drop in the comments. What do you want to know? What do you want to hear? We've got so many avenues we could explore, and at the moment we're fixed around the major topics of RAM analysis, design for reliability, and things like that. So if there is more you want to explore, please do comment in the comments and let us know what you think. So back on the topic, RCM++ availability, optimum replacement, task management. Something we didn't touch on much was failure effect categorization. Where is it? How do we handle it? And what's it all about?
So this is the one where you categorize your effect, whether it's hidden or not, obvious, and so on. Yes, I mean.
Exactly this matrix. Exactly this matrix. I think this originally came from this aircraft standard. Yeah, that was one of the part of the task selection logic. Yeah, so we are trying to, after the identification of the effects, we are trying to understand what would be the consequences. And usually this is like with the questions in the top. If this consequences of this event will be obvious or hidden for the operator. On another step, you are asking if it will be safety issue, and then if it will be operational, and then you can end up. It depends on a tree with the 4, 5, or 6 different categories. That is first step of the determination of the optimum maintenance. On the next step, based on the categories, failure effect categorization, you are going to the next step, asking what the maintenance tasks are feasible and worth doing. Yes, of course, if you have a hidden failure, yeah, usually the failure founding inspection is required. Yeah, so that you need to first see, yeah, if that failure occurred. Yeah. And then you can perform the corrective task, yeah. And of course depends if it has even hidden can have a safety or just operational or economic consequences, yeah. So it depends, but yeah, as you said, failure effect categorization usually the first step of the finding the optimum maintenance task.
Yeah, that's great. Thank you.
And in our tool, of course, we have this matrix implemented, yeah, in a user-friendly way, yeah. So you are going from the top to the down, yeah, with this few questions that should be answered, yeah, to get the proper maintenance activity, to not end up with the run to failure for the hidden safety things, yeah, and
no. We don't
catastrophic effects, yeah.
That's a good example of what not to do.
Exactly.
It's the whole point of failure effect categorization. Absolutely. The last thing we want to do is run to failure on things that are safety critical.
Yeah, because this is how you are. If you will go with the RAM analysis, yeah, going just with the RAM analysis, you don't have because RCM promotes the functional thinking, functional understanding of the system that we are preserving of not the asset but actually the functions. Yeah, so this is not like RAM analysis. RPD is not so in deep like this. And another thing, it's easier to catch all of the safety things, yeah, with the RCM methodology instead of doing just RAM analysis. But of course, both they are playing together when they are doing both, yeah, together, yeah, with the good flow of the information between the teams, yeah. If the two teams are doing this separately, yeah, but should be integration of both analysis, of course, yeah.
Okay, so bouncing back to BlockSim, with regards to maintainability, we in the design for reliability world, or design for design for availability and things like that, we've got putting things into parallel, putting things into AND gates, if you like, in a fault return, of introducing redundancy. So with BlockSim, we can introduce that redundancy and see what that redundancy impact is, and we have to maintain that redundancy at the same time. So the failure effect categorization analysis on that part, identifying that we've got hidden failures, for example, we can take that to BlockSim and we can duplicate, or we can introduce a safety measure that's in place, depending on whether you're doing a product, system, or service, whichever it is that you're analysing. And with that redundancy, it will then allow us to produce a simulation based on a system that has redundancy, has a safety margin, has safety factors built into it. So we then can use that for justification for adding that additional feature in. So as you mentioned, Bartek, with aerospace, Redundancy is a big thing in aerospace. The last thing you want is something to fail and then there's nowhere else to go but failure of the overall system. We don't want that. It's things that fly. It's not a good idea. Whereas maybe a vehicle, not necessarily that important for redundancy unless it's in a military term mission critical. It's that vehicle. If you think of it from a civilian point of view, maybe a train. Something failing makes the train stop. That is a business sensitive issue, not necessarily a safety issue, but business sensitive, which could be just as important as safety. It's just it's going to impact the service and going to impact their credibility in a big way. So having that redundancy can protect that in multiple ways. So just a recap, we take the failure modes and effects analysis. We can do RCM analysis on that failure modes and effects analysis using the reliability policy from the failure effects, from the failure modes and reliability analysis. We can then, with that information, understand and identify tasks with the help of failure effect categorization as well, to help with the selection of the right tasks in the right places. And all of that analysis can then be taken to another level using the BlockSim tool to introduce redundancy, to introduce the maintenance strategy, and then to simulate the whole thing to give you some idea of some predictions for the future of that system based on either a modification or the creation of a system from scratch. And you can simulate it to give yourself an idea of what it can do. The analysis that we are doing is intended to be live with the product or asset, product, system or service, with the asset that the analysis is intended for. So when something changes, you can take the information from that change back to your simulation and then simulate that issue, and then get a more accurate simulation. So over time, the analysis and the simulation improves with your asset as you track your asset with the software. So is there anything you'd like to add to that, gents, before we close for today's episode?
No, I think you summarized it very well. Thank you, Chris.
Yeah, as you underline, this is living analysis, both RAM, RCM, more data, more information, better understanding of our asset. We always need to update our strategies to find the one that is most optimum nowadays. Of course, technology are changing, of course, as well, especially for the predictive maintenance, that the one strategy that I not touched before, so new opportunities, new ways how we can maintain and preserve our assets, preserve our actions, actually. Functions, sorry.
Thanks for watching for today. You've just been watching episode 6 of our series. If you haven't seen the other videos, please go back and find them, watch them, and this video should make a lot more sense. It's part of a full series, so go do that. And again, any comments, any topics you want to discuss, please put them in the comments below, somewhere down there. If it's YouTube, I'm not sure where it is in LinkedIn, but YouTube and LinkedIn is where these videos are kept. And give us a thumbs up, like us, share us, subscribe, the usual lingo for these things. And we'll see you in the next video. Thank you. Bye-bye.
Thank you.
See you. Thank you, Chris. Thank you, Mariusz.